previously looked at how fines migrate and how coffee can migrate, and I wanted to try what would happen if we force some migration of particles. So I did this using Kompresso and some spent coffee grounds, where I put them in and I agitated the water continuously so that flow of water downwards wasn't too much. And what happened was a lot of the smaller particles came up from the top screen after a while and filled the top chamber. And then I eventually pushed those out. So I wanted to see if you loosened up the particles in a very forceful way, how much coffee would come out at the end. And then I could compare that against using the same experiment with the water pushed down directly with pressure and no agitation like I did here. So I went a while longer to see how much could come out, and then I flushed the water all the way through, and then I saved the coffee puck to do some measurements after the fact. And then I saved the water from each one to where I could measure the how much particles came through the cup. And since you weren't contending with carbon dioxide release or from extraction solubles coming out, you didn't have anything interfering with flow. So I cleared out the water and I added more water and did this again. And then I think I did this one more time. There's fewer particles the second time. And then I'm just letting it push all the way through. And I fill it back up with water one last time. Which again, there's not much left now. And most of the particles actually went through the puck at this point, and it was very cloudy at the bottom that was released. So then I continue to agitate this, and again, much fewer particles are coming in through here, so I think I got most of the particles through the first round of this, but I wanted to be extra sure. So then I show, oh, did I do this another time? I guess I did this another time, just to be double sure. So I flushed the particles through, or the water through, and can see the outcome. Okay, so let's see what's in there. There's not much in there now. So this was from the top water, the water that's on the top of the puck. This is from the bottom of the puck. And then I took the puck out and I cut the top, the middle, and then the bottom to take measurements later once I dried those, and I could compare those to the spent grounds. So then I did the same experiment with no agitation, just straight pressure. And I pulled out the puck a few times, which may have caused some agitation, but it's very little in terms of the amount of coffee left over. So I did this a few more times, and the main caveat here is that when I pulled the plunger out, that could have caused some water to pull back on the puck, but it was not nearly at the same level of agitation as the previous. And then I have some cuts to shorten the video, just showing when I pulled off I started to unscrew the top so I wouldn't have that problem. And I could reduce variables here. And when it was coming through the puck, it was coming through very evenly. The amount of coffee here is about 15 grams of spent grounds in. So that's the outcome of pushing it straight through. There's very little that you can see in there. So then I dried these. So this is what it looks like from the bottom of the first experiment. This is from the top of the puck. And this is from the bottom where I pushed through in the second experiment. So this is 0.01 grams. From the first experiment, on the bottom, I ended up with 0.29 grams, and then on the top of the Kompresso, there was 0.06 grams. So in total, 0.35 grams of particles came through in this forced migration experiment, as opposed to 0.01 grams, or that could be plus or minus. So it could be closer to 0, it could be closer to 0.02, because the scale I have, the accuracy is only up to 0.01 grams. Whatever the case is, when you're doing regular shots of espresso, you're not getting this type of agitation, which means that you're not getting nearly the type of migration that you could if the particles were in this kind of constant motion. These are the grounds from the bottom. This is the grounds that came from the top. These are very powdery, very fine. This is the ones that came through. Just a little bit more than 1/4 of a gram. However, they're very, very fine. Hard to measure. So I took these particles and I looked at the top, bottom, and middle of the spent grounds. And then I looked at the original spent grounds that went in to see what kind of movements we saw in terms of what particles got taken out. So the top and bottom have more finer particles relative to larger particles. And the middle aligns more with the spent grounds, which would kind of make sense if you're agitating the particles more on the top or the bottom. And in looking at like the distribution that's not cumulative, you can see that they had these major peaks. The spent grounds at the between 200 and 400 microns. And so a lot of the particles, the smaller particles and these larger particles, went through the puck and went into the cup. And I tried to measure those, but they were very fine, and they were hard to declump to where I could get a really good measurement on them.